From stars to Google Maps. Hey everyone, Marvel Smith here, and today we're going to be talking about the history of navigation. Wait, what do you mean stars? Let me explain. Okay, so there is a star called the North Star, and it's called that because it always lies above the North Pole, and it stays that way. It never moves. And the scientific name of it is Polaris, which also makes sense because it lies above the North Pole. If you're if you're lost and you're facing the pole star, then you know you're facing the north, and to your left, I mean to your right, it would be east. Behind you, it would be south, and to your left, it would be west. And you may be asking me, well, how do you find the North Star? Now here you can see the Big Dipper. This is the constellation of the Big Dipper. And at the end you can see these two stars. And if you go straight, you can see the pole star is almost in line with these two stars. And the pole star, as you can see, if you just see an imaginary line and you draw another imaginary line of the horizon, then this angle right here would be your latitude. And if you don't know what latitude and longitude is, then I'll explain it to you later. And something interesting you may not have known. Um, it is said that the pole star is the exact same star that the three wise men in the Bible followed to baby Jesus. Okay, now let's move on to something that you all know, a compass. But not the compass you all know. This compass was used by the ancient Chinese 2,000 years ago, but it wasn't used for finding the directions. It was actually used for divination. And divination is basically mystic future telling. You might have heard about it by Harry Potter, because in Harry Potter he has a class at Hogwarts called divination. Okay, so here's the compass we all know and love. And you might have thought to yourself, well, how does this thing work? It works with the help of the Earth's magnetic fields. And then you might ask, what are magnetic fields? Where they are the magnetic lines around the Earth. Kind of like as if the Earth is a magnet, which it is. So the North Pole arrow on the compass points this way, and the South Pole arrow points this way. Okay, now let's go back to something you really want to know. Latitude and longitude. At school, if you haven't learned this at school already, then consider yourself lucky, because when I learned it at school, I was like, why you make no sense? And I do know that you can't say longitude as longitude. Technically it's correct, but if you're talking to me and you say longitude, then I'm going to cut you out of my life forever. So you might be asking, what are these lines on the Earth? Well, this line is 0 degrees. The one after it is 10 degrees. The one after that is 20 degrees. The one after that is 30 degrees, so on and so forth. And latitude is actually a bit harder. Instead of being the same thing, this is the equator. And, oh yeah, by the way, these are all imaginary lines. They're not actual lines. Yeah, so this is the equator. And the North Pole from here is 90 degrees. And this side would be 0 degrees. So this is a right angle. And so in the middle, it would be 45 degrees. And yeah, so that's basically latitude and longitude. It's really not that hard. But the way they taught me in school, I was infuriated nonetheless. Okay, now the real reason you clicked on this video. You want to know how GPS works. And GPS stands for Global Positioning System. And a huge misconception of GPS is that the whole world uses GPS, except that's not true. GPS is only used in the US. India, China, and other countries use something different, but all of them work the same way. At first, GPS was used in World War I for soldiers to get where they have to go, and it works by something called trilateration, where there are three satellites, and this is just a two-dimensional diagram so that you can understand better. So there's one satellite here, another satellite here, and the third satellite, and they all cast circles around them. And the one that overlaps with all the circles is where you would be. So this circle is right here, and then this circle, these two overlap, and then this circle, and boom, it knows where you are. Okay, now we're working with a three-dimensional space. There are three satellites. This one casts a sphere, not a circle, a sphere, and this one also, and the other one. And they all overlap, but there's one problem since it's in the third dimension. There are two places you can be instead of one. You can either be here or you could be here, like this. And some say you would need a fourth satellite, but honestly that's really not necessary, because the two options are A, in space, or B, on Earth. And I think we're all on Earth, so we can go for that. See, the ground stations send signals to the satellites, and the satellites send signals to the receivers, which can be any device like a phone, or a tablet, or even a sat-nav. Okay, now you might be asking me, what's the difference between sat-nav and GPS? Sat-nav stands for satellite navigation. And technically sat-nav does use GPS, but it integrates it to a map. So technically Google Maps is sat-nav. It's meant for traveling when you're in the car. And that's it for today. I hope you guys liked the video. If you do, leave a thumbs up. If you didn't, leave a thumbs down. I don't care. And peace out.